So let's start with a generic overview of the boot procedure. When your computer starts up, the first thing that happens is the power on self-test. From the power on self-test, all the hardware is checked and the computer finds its boot device. And that would typically be your hard disk. On the boot device, it gets access to grub2, and that is the code that allows the computer to load the kernel and the init.rd. From there, the root file system can be mounted, and once that has happened, systemd is accessed. It is interesting to know that the root file system is mounted from the kernel, and systemd is started after that. And once systemd is loaded, well, everything else can start happening, like logging, like mounting the other file systems, like starting services, and like preparing a login shell. So let's start with a generic overview of the boot procedure. When your computer starts up, the first thing that happens is the power on self-test. From the power on self-test, all the hardware is checked and the computer finds its boot device. And that would typically be your hard disk. On the boot device, it gets access to grub2, and that is the code that allows the computer to load the kernel and the init.rd. From there, the root file system can be mounted, and once that has happened, systemd is accessed. It is interesting to know that the root file system is mounted from the kernel, and systemd is started after that. And once systemd is loaded, well, everything else can start happening, like logging, like mounting the other file systems, like starting services, and like preparing a login shell. The very first thing that happens from the Linux perspective when your computer boots is grub, the Grand Unified Bootloader. So let's have a look at grub2 and its configuration. In grub, the etc default grub is the most important configuration file. That is typically the file that you would change if anything needs to be modified. And there is some additional configuration files in the etc grub.d directory. You will rarely access that, but in specific cases you may need to make some modifications in there. You will see that if you have a look in the files in this directory, most of them are pretty complex. If you have applied updates to any of the configuration files, you need to update the bootloader. And a big difference between grub2 and previous versions of grub is that it doesn't happen automatically. You need to manually do it by using the grub2-mkconfig command. And that would update the data in the master boot record and in the metadata area of your hard drive. So once your computer boots, you can access the grub boot menu by pressing escape. And once you've done that, you can specify specific options, like systemd.unit equals emergency.target, if you need to start your server in troubleshooting mode. We will see that later in this lesson and in the next lesson as well. Now let's look how this all works from a nice diagram. So your computer is doing power on self-test and the master boot record is read. Once that is done, grub is loading and you can press escape to access the boot menu. And from the boot menu, you can enter boot options like systemd.unit equals emergency.target. And that is a temporary modification. In case something is wrong, you want to make permanent modifications. And the permanent modifications should be written to two locations, to the file etc default grub and to the directory etc grub.d that contains separate files that you can modify each individually. And once you have applied modifications to these files, you need to write the modifications using grub2-mkconfig. And that makes sure that the next time your master boot record is read, the modified grub configuration files will be used.
To change the grub configuration in grub2, you need to start with the grub file in the etc default directory. Please do remember, if you have worked with previous versions of grub, grub2 is completely different. So forget everything you knew already and start all over again. So in default there's the grub file, and in this grub file you can see what exactly is happening. So the grub timeout is the amount of time that the system will wait for you to do something. You think 5 seconds is a bit short? Change it to whatever you want. Next, there are some other options that are not so very important. The most important option is the grub cmd line, which is the command line. These are all the arguments that are passed to the kernel while your system is booting. There are some options here that you probably don't like, and that is RHGB and quiet. This makes that grub doesn't tell you what it is doing while it is booting. So let me save this. And let's have a look at the rest of the configuration as well, which is in the grub.d directory. This is normally not something that you would edit manually. Just to give you an impression, the 10_Linux, as you can see here, that's quite a complicated shell script. Don't touch anything here, it's really not meant to be changed. So what about the custom scripts? Well, these are just some standard things that are added by the operating system itself. So better don't touch it. After changing the grub configuration, you need to compile the information back into the bootloader, and to do that you'll use grub2 mkconfig. This is reading everything, as you can see, and the result is written to the bootloader. And to see it, well, you need to reboot your computer. So this is the grub prompt that you will see when you are rebooting. In order to verify that the changes have been applied correctly, you can go into the grub menu and go all the way down to the kernel line, and in here you can see the kernel line with all the options that I used. So press Ctrl X to start and finish the boot procedure.
So let's talk about systemd. Systemd is the major new thing in Red Hat Enterprise Linux 7. And to summarize it in one word, it starts things. So basically in the boot procedure, right after loading of the kernel, systemd is started. And systemd takes care of starting, well, basically everything. It's not like the old run level system where just services were started, but systemd takes care of starting services, and it takes care of doing mounts. It can even do auto mount, and it can do other things as well. Now, in order to understand systemd, you need to know about the unit file. So a unit file is basically the replacement of the old init script. Where init scripts were relatively difficult to understand and normally long bash shell scripts, a systemd unit file is very simple to understand. Never is it any longer than about 20 lines, and it's just 20 lines that are easily readable. So the unit file defines how to start services, how to mount file systems, how to auto-mount file system, and it defines relations between all those things. Now, in order to understand systemd, you should know that there is two different types of scripts that are used. There are scripts in user lib systemd, which are the default scripts that you are just going to use as an administrator. But if as an administrator you want to modify anything as compared to the defaults, well, you can put your own scripts in the etc systemd directory. And in the next couple of sub-lessons, In this lesson you will learn how to do all that for yourself and how to start and stop services using systemd.
To get something done in Linux you need services, and to start services you need systemd. Now let's have a look at the configuration of systemd. There are two directories that are involved. There's user lib systemd system, which contains server scripts and many more. For the moment I just want to look at the server scripts and ignore everything else. Now user lib systemd system is for default services that are installed from the RPMs. So the bottom line is, don't touch it. If you need to do anything specific for your system, you go to etc systemd system and put a server scripts or whatever you want in here. This is what is really going to define the behavior of your system, and this is also going to override everything that happens in user lib systemd system. So your personal configuration will always win from the system-wide configuration. Now the basic unit in systemd, as I just explained, is the service. So let's get back to user lib systemd system, in which we can see lots of service files. So what exactly is in a service file? Well, that is basically everything you need to start the service. Let's take for example httpd.service. You should understand, by the way, that a service in systemd is so much more than a service in previous versions of Red Hat Enterprise Linux. You can basically make everything a service and have systemd take care of it. But to start with, I will have a look at a traditional service like httpd.service. So there we go, we see a small description of the service. Now in this description we start by the bottom line, which is defining how the service should be started. It should be started by a target. I will explain targets after this, but I already want you to be aware that services are assigned to a target and the target takes care of starting up the services. Next we can see the service definition itself, which is kind of cool because everything that before was in very big shell scripts is now in a small section containing no more than 10 lines and defining exactly what should be started. Okay, to manage services, well, the command to do that, you've already seen it a lot, it's systemctl. So we have seen systemctl status httpd, for example, which shows the current information about the httpd service. You can see much of information about the service. So the fact that it is loaded, its current state, its PID, cgroup information and log messages as well, which is pretty cool. Some other relevant commands are systemctl stop httpd, which is going to stop the service, systemctl disable httpd if you want to take it out completely out of the startup procedure of your operating system. And look at this, by disabling it I'm modifying some files in the multi-user.target.once, which we will discover in a bit more depth in a few minutes. If I want to start the service again, systemctl start followed by the name of the service, and if I want to make sure that it gets back, then systemctl enable httpd will do the trick. And as you can see, it's creating some symbolic link in the multi-user.target.once directory. Good. Now let's talk about the way that services are started up. Your system can enter different states, and these different states, these are the targets. The targets also are defined in the two directories that we've just discussed. So user lib systemd system and the other one in etc. So if I do an ls star target, I can see all the targets that are available. Now you should see a target just as a collection of services. And yeah, you can specify dependency relations within the target file. Now there are two targets that are more important than other ones, and that is the multi-user target, and then we've got the graphical target. The graphical target is what you start as the default environment if you have a graphical user interface running, and the multi-user target is what is used on servers that don't have a graphical user interface running. So the idea about targets is that servers belong to a specific target, and to take care of that, well, that is what really is happening when you enable a service with a command like systemctl enable, as we've just seen. So when you enable a service on your operating system, a symbolic link is going to be created in a once. Now what exactly is a once? Well, a once defines what a specific target really wants. Right now I'm in user lib systemd system, and we should have a multi-user.target.once directory containing symbolic links specifying the services that should be available in a multi-user target at all times. Please do remember this isn't all, because there's also etc systemd system where you can put in the rest. And in here you can see there's also a multi-user target.once. So if I go to the multi-user target.once, and we have an overview of services here. Let's make it a little bit more readable by putting a backslash in front of the command. You can see all the services, and these are the services that are always started in the multi-user target.once. So in order to define what should start up by default, in the etc systemd system directory we have the default target. So let's do an ls-l on default target. Hey, and I guess you get what it's doing. So default target is a symbolic link that really sets to a lib systemd system graphical.target. So if you want to change the graphical target to a multi-user target, just change the symbolic link. Also, if you want to find out which targets are currently active, well, systemctl list units -- type equals targets will do the job for you. So the interesting thing here is that you see that multiple targets are currently active, and that is also something that is specific to systemd. It is not so that your entire operating system configuration is in one target. Targets can just work together, and this working together is also something that you can further define, which is in user lib systemd system. And in there, if we have a look at the multi-user target, you can see what it conflicts with, what it requires, and after which it should be loaded. So in the case that I wanted to run the multi-user target but basic target isn't started yet, well, requires is telling it that it needs basic target, and that allows it to start basic targets as well. And that is how systemd is working. So let me resume it, because I know that if you come from a distribution where systemd wasn't used, it is kind of complicated. So we have the service. The service is taking care of starting specific things on your operating system. We have the target, which is a collection of services. The target itself defines dependencies with other targets to make sure that everything is started that is needed. And in order to put services in a target, you will create a once. A once is a symbolic link that is created automatically when you're doing systemctl enable on a service. And that is basically all you need to know about systemd.
So we have talked about the systemd unit files. The unit files is basically everything that can be started by systemd. A specific type of unit file is a systemd target. So let's try to understand what systemd targets are doing. So systemd targets define the state your system enters. Basically, a systemd target is a collection of unit files that belong together and that are used to enter a specific state. And some of the systemd targets are equivalent to run levels in previous versions of Red Hat Enterprise Linux. For example, there's poweroff.target. That is the state that will shut down your computer. There is rescue.target, which helps you entering troubleshooting mode. There is multi-user.target, which is the fully operational mode of a server without a graphical user interface. There is graphical.target, which does start a graphical user interface as well. And there is reboot.target, which brings your computer to a reboot. And also there is emergency.target, which is even more a minimal mode than rescue.target. We will see some of these targets shortly and we will see the differences between them. Now the services need to know about the targets and the targets need to know about ordering. So every service typically knows by which target it is wanted. And that is what we call a want. So in a server you will see a section like install wanted by multi-user.target. And then you can see the order between targets that is defined in the targets as well. So here you can see the unit, and the interesting part is where you can see it requires basic.target. So this target can only be activated after the basic target. It cannot live together with the rescue.service and the rescue.target, and it should be loaded after basic.target and rescue.service and rescue.target. And allow isolate means that you can jump from another target to this target to change the current state of your system.
Let's talk about switching between targets. To some extent it is possible to switch to a different systemctl target from an operational environment, but in many cases you just can't. I will shortly show you how we can switch from an operational environment to a minimal mode like the rescue mode. The other option is to specify which target you want to enter from the grub boot menu, which I will present after that in this short presentation. So to start with, it's a good idea to get an overview of what exactly we have. And that is accomplished by typing systemctl list units --type equals target. As you can see, it's not just one target that is loaded, but a working environment like this consists of multiple targets. You may remember from the previous lesson that in the target file dependencies between targets are defined. So right now I am in a graphical mode. If I wanted to change to another mode, I can use systemctl isolate. And that is, for example, followed by rescue.target, which brings me to a minimal mode. There you go, I'm in the minimal mode and I have to type the root password to do whatever I want to do in here. So in rescue mode, let's do systemctl list dash units --type equals target again, which gives an overview of everything that is included in the rescue mode. As you can see, this is quite minimal. To get back to multiple user mode, you just type exit to close rescue mode. It's not possible to switch from rescue mode to any other target in an easy way. Another way to specify which target you want to start is from the grub boot menu. In the boot menu, type E, which opens the grub menu settings. Go down until you see the line that starts with Linux 16, and at the end of this line specify systemd.unit equals rescue.target. Then press Ctrl X to start your system. Once you have entered rescue mode, type the password again to get full access. In rescue mode you can also type systemctl list units type equals target to get an overview of all the targets that have currently been loaded. As you can see, there's still a few of them, like the sysinit target and the local fs target, which are quite essential. After finishing your work in rescue mode, press Ctrl D to get out of there and start normal functionality again. Another target that makes sense to start from the grub menu is emergency mode. So do E again and back to the line that starts with Linux, and you just add systemd.unit equals emergency.target. Ctrl X again to start your system into emergency mode. Also in emergency mode you need to enter the root password. In the next section I will show you how you can log in case you don't have the root password, but for now let's just enter it to get into the emergency mode. And let's also see what exactly we got here. So systemctl list units type equals target, and that doesn't give us anything, and that is because we're in emergency mode. You can also see here in the upper lines of the emergency mode that it's welcoming us to emergency mode, and we have to do systemctl default or systemctl reboot to get out of emergency mode. So let's just do systemctl default to start the default systemctl target. In previous lessons we have mounted file systems through the etc fstab file. That's the classical way, and that still works. But this is a systemd system, and on systemd you can use systemd to mount file systems as well. You may even have noticed that not all file systems are available through etc fstab, and that is because if you go to user lib systemd system, where we can see all the different systemd units, you can see a lot of them. If we do an ls star.mount, we can see the mount units, and that contains some file systems that need to be mounted at all times. For example, there is tmp.mount. If you look at the tmp.mount, we can see the unit specification, which is just very generic, not very important. The important part is the mount specification. So what is the device that's going to be mounted, TMPFS in this case, and where is the TMP directory, and the type is TMPFS, and we have some mount options as well, and we have it wanted by the local file system target. So if you wanted to do something like this for yourself, you can put a mount file in etc systemd system. You see there's not much here. Let's make sure that we have something to mount before we go on. So we have this dev vg disk lv disk. That is the XFS logical volume that I created in a previous exercise. And I want to mount it on the directory lv disk. So I would create a file with the name lvdisk.mount, and in this file I need a unit description. So description equals my test mount. You could of course also have copied over a valid unit file that is already used to mount file systems. Next I need a mount section, In the what part, I will specify dev vg disk lv disk. In the where part, let's use lv disk, and in the type part we are doing xfs. Also, we want this mount to happen automatically, so we need it to be wanted by something. Wanted by equals multi-user dot target. And that is basically it. It's really not difficult. If you know how to find an example file, it's easy enough to create such a file for yourself. So let's first do mount pipe grep lv disk. Oh, it was already mounted. That is no problem. We get rid of that. No, it isn't. And the next thing we need to do is systemctl start lv disk dot mount. So do we have it? Let's verify, and it shows us that it is active. Don't you like this status output? It tells us where and what, so it looks all cool. The only thing we need to do now is to make sure that it comes back after a reboot. So systemctl enable lv disk dot mount would do that for us. As you can see, it has created a symbolic link in the multi-user target.once directory, which makes sure that it will be started automatically from the multi-user target. Systemd also takes care of auto mount. The start point of creating an auto mount configuration is to create a mount file, as we have just done before. The mount file basically specifies the file system and everything else, but in this case you don't want it to be mounted. You want it to be mounted automatically if some activity is happening on the auto mount directory. So to do that, we first need to disable the mount file. Let's do an ls again. We can see the name of the mount file is lvdisk.mount. So we are using systemctl disable lvdisk.mount to make sure it doesn't get back when the system starts, and systemctl stop lvdisk.mount, which disconnects the mount. Let's just verify that. Mount pipe grep lv disk, and we cannot see it. The next thing, we need to create an auto mount file, which is directory name .auto mount. So lvdisk is a directory name, so the name of the file would be lvdisk.auto mount. And in this file we need to put a short description. So unit header with a description equals lvdisk auto mount. Then we need an auto mount section, which tells us where it has to be mounted. Where equals /lvdisk, and then we need an install section where we tell it that it is wanted by the multi-user.target. What is very important here is that the name of the auto mount file matches the name of the corresponding mount file. Now at this point I can enable and start the lvdisk.auto mount file. So systemctl enable lvdisk.auto mount and systemctl start lvdisk.auto mount. So if at this point we go to lvdisk, we don't see anything, but if we do a mount pipe grep lvdisk, we can see that it has automatically been mounted. And that is how you set up auto mount from systemctl. So you have a choice here. If you like the option that we have previously discussed, you're good to go. Just use the AutoFS service. If you like this option better, go for this. You should realize though that the previously discussed option, although it still works, it isn't the option of the future. This is definitely the option that you want to be using in future versions of Linux.
So now that we have covered system startup, let's have a look at the exercise. I would like you to restart your server. Next, at the grub boot prompt, interrupt your system and enter the emergency target mode. And from the emergency target, switch to the graphical target. From there, create a 1 GB logical volume and create a systemd auto mount configuration that mounts it on /test automatically when that directory is accessed.
So the first question was to start the emergency target. To do that, you go in the grub menu and you look for the kernel line. And at the end of the kernel line, I'm going to remove RHCB and quiet to start with. And next, you can specify systemd.unit equals emergency.target. And let's just verify that I didn't make any typos. No, I didn't. So I can use Ctrl X to start booting. At this point it asks for the root password. So let's enter the password and do whatever troubleshooting we need to do. Of course we are in a read-only file system, so let's start by doing mount -o remount, rw on /. And let me get rid of an annoyance to start with. That is the etc crypt tab. I don't want my system to ask for the encryption password anymore. And I also need to take out the Lux encrypted volume from my FS tab. So once you've finished your maintenance, you can move on and start another run level. The next question was to take one of the existing file systems and create an auto mount for that. So let's have a look what we've got. fdisk-l on dev sdb shows me that I have my SDB5 and I have my SDB6 that apparently seem to be available. SDB5 was the file system that we created before as an ext4 file system. Let's just do a quick check. Mount dev sdb5 on /mnt. If you want to configure auto mount, it's always a good idea to confirm that you can actually mount the file system. So this is what we're going to use. So to create an auto mount, we need a directory, we need a mount systemd file, and we need an auto mount systemd file. Let's create a directory with the name test as requested in the exercise. Next, as this is something that we are manually adding to the system, we are doing it from etc systemd system. And what we're going to do there, well, we are going to create a file with the name test.mount to start with. And in the test.mount we put a unit description, followed by description equals test mount, followed by what exactly we need to occur on the mount. So what is dev sdb5 and where is /test, and the type is ext4. And we need this to be available in the multi-user target. So that's the first part, and it's a good idea to test if that works before we go on. So systemctl start test.mount. And let's verify by doing systemctl status, and we can see that it is mounted. So that's all good. Now that we have verified the mount, we can proceed with the auto mount. Before doing that, it's a good idea to make sure that the test directory is no longer mounted. You can see it is mounted here. That's not good. So I'm doing umount/test. Because if it will be mounted, we won't succeed in getting the auto mount to work. So at this point we need a file with the name test.automount. I can show you the contents of the file that I already created. So there it is. The description in the unit section is just a description. Automount contains a where equals /test, and install contains a wanted by equals multiuser.target, which tells it to come up automatically in the multiuser.target. Now at this point we can do a systemctl stop of test.mount, because the test.mount is not supposed to be running. Let's verify that by using the status command as well. We can see it's inactive, dead, which is good. And now we can do systemctl start test.automount. Let's do a status as well on that one. And we can see that it's active, which is also good. So if we do a mount pipe grep on test again, we can see that systemd-1 is on /test, which is what you normally see for an auto mount. And this completes the exercise.
And this brings us to the end of lesson 19. In this lesson you have learned how your Red Hat Enterprise Linux server boots. We have talked about the grub2 bootloader, which is used to boot the kernel and which allows you to enter the grub2 boot prompt during boot if you need to troubleshoot whatever is happening. And we have talked about systemd and how it is used to make sure that everything on your system is available and makes your system ready for use.